Hi guys, how are you doing? Welcome back to Physical Chemistry Lecture Series. Today we are going to discuss about complex reactions, otherwise composite reactions or complicating reactions. Generally, most of chemical reactions are not simple and straightforward. Instead, several other reactions will be takes place simultaneously along with the main reactions. Hence, the interpretation of the rate of the reaction becomes quite difficult, and the smooth progress of the reaction is disturbed. Therefore, the chemical reactions which takes place in sequence of elementary reactions are called as complex reactions or complicating reactions or composite reactions or multi-step reactions. For instance, let us take the examples. So first one is combination of hydrogen and bromine. Combination of H2 and Br2. Okay, so it is the gas phase reaction. So in the gas phase, H2 gas combined with the Br2 gas. H2 gas is combining with the Br2 gas. Then we can get the 2 moles of the HBr, which is also gas. Okay, so this is the an example for the complex reaction. So here H2 is combining with the Br2 and giving the 2 moles of the hydrogen bromide. This reaction is looks like a simple reaction, but it is not the simple reaction. So along with this reaction, many several reactions will be taking place. Okay, so many several reactions will be takes place. So if you take the elementary reactions are several other reactions or side reactions. So that first one is, so in the first one, in the step one, what happens? So generally if we heat these reactants H2 and Br2, among them Br2 will be undergoes homolysis initially. So bromine is undergoing homolysis. Lysis. It is undergoing the homolytic cleavage and giving the bromine radicals. 2 moles of the bromine radicals. Okay. So once you can get the bromine radicals, immediately they will be combining with the hydrogen molecule. So in the second step, bromine radical is combined with the hydrogen molecule. So Br dot plus H2 gas. H2 gas. There we can get the what we can get. So there we can get the HBr. It is HBr plus what we can get hydrogen atom or hydrogen radical. So again we have the free radical. So in the third step what happens? So in the third step hydrogen radical again combining with the bromine molecule. So it is H dot plus Br2 gas. Then we can get the HBr. HBr plus we can get the Br radical. Okay, so Br radical. In the next step, what happens? In the fourth step, 2 moles of the bromine atoms or bromine radicals combines and give you the bromine molecule. So it is Br dot plus Br dot will give you the Br2 gas. So these are the elementary reactions which will be taking place in the formation of hydrogen bromide. Okay, formation of the hydrogen bromide. So now if you want to get this whole reaction, we need to add up all the elementary reactions. Okay, so if we add up, what we can get? Let me see what we can get. So here what happens if we add up bromine radicals? Okay, so these bromine radicals will be cancels. Okay, yes. Later which one will be cancels? This bromine and another both will be cancels. Later hydrogen hydrogen will be cancels. After this bromine, yeah, bromine, and this one will be cancels. So remaining one is, so what remains? One is Br2, yeah, Br2 gas plus H2 gas, H2 gas. There we can get, what we can get there? One HBr, another HBr. Anything else? No. We have the 2 moles of the HBr. So this is the overall reaction. Okay. So in order to get the 2 moles of the hydrogen bromide, we have the several elementary steps. Okay. That's why this reaction is the complex reactions. Therefore, the chemical reactions which takes place in sequence of elementary reactions are called as complex reactions. And a collection of the elementary reactions which would be added to result in overall reaction is called as mechanism. So this process is called as the mechanism. Mechanism means, how we are defining? A collection of the elementary reactions which would be added to results and overall reaction is called as mechanism of the reaction. So this is about the mechanism of the formation of HBr. And second example is, we have to take another example. So second one is thermal decomposition of acetaldehyde. Thermal decomposition of acetaldehyde. Okay, thermal decomposition of the acetaldehyde. It is also an example for the complex reaction. So let us take this oral reaction. It is CH3, C double bond O H. It is the acetaldehyde. So on thermal decomposition, we are getting the methane and we are getting the carbon monoxide. So generally 2 moles. It is also 2 moles. 2 moles. So assume it is in the gas phase. Actually, acetaldehyde is the liquid. Just we are assuming it may be in the gas phase because we are heating it at high temperature. So it is also gas, and this is also gas. Okay. So this is the second example for the complex reaction. So here also what happens? If we want to get this methane and carbon monoxide, so we don't get it directly from this acetaldehyde. Okay, so initially what happens? Acetaldehyde will be, 1 mole of the acetaldehyde will be decomposes and give you the methyl radicals. So in the step 1, what happens? Yeah, in the first step. So in the first step, step 1. So there acetaldehyde is undergoing homolysis. Okay, so it is undergoing homolytic cleavage. Homolytic cleavage. Okay, homolytic cleavage. There you can get the one. Yeah. So there you can get the. So instead of the cleaving the CH bond, first CC bond will be cleaves. Okay, CC bond is cleaving. So there we can get the methyl radical plus we can get the parmyl radical. This is the parmyl radical. Okay, methyl radical and parmyl radical. So in the second step, if we take the second step, so in the second step what happens? This methyl radical, which is the reaction intermediate, so we will be combining with the another mole of the acetaldehyde. So it is CH3 dot will be combines with the another mole of the acetaldehyde and give you the methane CH4 plus we can get the acetyl radical. We can get the acetyl radical. And if you take the third step, so in the third step, parmyl radical and acetyl radical both will be combined. So What of is formyl radical and acyl radical. Formyl radical and acyl radical both combines together and give you the methane CH4 plus and carbon monoxide. So here you can get the 2 moles of the carbon monoxide. Okay, so if you take the mechanism of the thermal decomposition of acetaldehyde, so there we have the 3 steps. In the first step, 1 mole of the acetaldehyde will be undergoes the homolytic cleavage and give you the methyl radical and formyl radical. Later, that methyl radical will be combined with the other mole of the acetaldehyde and give you the methane and acetyl radical. Later, formyl radical and acetyl radical both combines and give you the methane and carbon monoxide. So this is about the mechanism of the reaction. So if we add up these two reactions, what will be remains? Let me see. So in the first case, methyl radical will be cancelled, and later which one will be cancelled? Yeah. So for this formyl radical, acetyl radical. Okay, so acyl radical, formyl radical, both will be cancelled. And anything is cancelling again, so nothing was there. So overall, how can we write the reaction? So here, how many molecules are involved in? 2 molecules. So 2 moles of the acetaldehyde is involved in the reaction and giving the 2 moles of the methane and 2 moles of the carbon monoxide. So this is about the mechanism of the thermal decomposition of acetaldehyde. Okay, yes. So now we have to take the important characteristics of these complex reactions. So if you take the characteristics again, characteristics. So what we can write just to observe the reactions. So here, what happens? These complex reactions are taking place in the multi-step. So that's why first characteristic is occurs in multi-steps. All the complex reactions occurs in multi-steps. And the second point is what we can say, these complex reactions are proceeds through the transition state and formation of the reaction intermediate. Okay. So all the complex reactions are generally proceeds through the formation of transition state as well as reaction intermediate. Further, the concentration of the reactant intermediate is not appears in the overall rate of the reaction. Okay, the concentration of the reaction intermediate is not appears in the overall rate of the reaction. So this is the second important characteristics. And the third one is the overall rate of the reaction is given by slowest step of the complex reaction. Okay, so the overall rate of the reaction is given by slowest step of the complex reaction. And the fourth one is the concept of the molecularity is not applicable to the complex reactions, whereas it is applicable to each elementary reactions. Okay, so the concept of the molecularity is not applicable to the complex reactions, whereas the molecularity of the each single step is defined. And the fifth one is, so in the complex reactions, products do not form directly from the reactants. Okay, products do not form directly from the reactants. And another characteristic is several side reactions takes place. Okay, so in complex reactions, several side reactions will be taking place. And next one is the overall order values are larger and greater than 3. Okay, so the overall order values are larger and greater than 3. Okay, overall order values are larger and greater than 3. Next one is the experimental overall rate constant values are differ from the calculated rate constant values for complex reactions. Okay, the experimental rate constant values are differ with the calculated values. And the next point is the theories of the reaction rates do not agree well on complex reactions. Okay, that means the theories are not explaining about the rate of the complex reactions. So this is about the important characteristics of complex reactions and a few examples. So now I will stop here. Tomorrow we will continue.